Okay guys, so today I'm going to talk to you guys about encapsulation. Today we'll cover encapsulation. Encapsulation is known as the first principle of object-oriented programming when writing OOP code. We should strive to use encapsulation. Encapsulation is all about protecting objects from being changed by other objects. We want objects to always be in control of themselves. So you see class 1, I'm changing, and then it goes to class 2. So you're just throwing the object. And it's just about the protective layer, what's going on. So here, encapsulation, class 1 and class 2, throwing an object of a please ask. And here, class 2 is changing that. Okay, so it's very possible that someone might say to you, well, yes, you use classes and objects, but you didn't use encapsulation. Therefore, your code is not true OOP. Other programs would disagree. Again, programmers like to argue about what OOP really is. Regardless of splitting hairs, encapsulation is a good thing, and we should attempt to leverage it in our code. So what is encapsulation and why do we need it? To understand what encapsulation is and why we want to encapsulate data, we need to go back and remember what program state is. So program is a state. You go to one cloud to the next cloud, and it's trivial. If you recall from JavaScript, all applications, including web applications, have state. If you can freeze the program or website in time and inspect all of the variables and objects, that is state. Is our mug full or empty? That is a state. How many animals, objects are running around? That is state. Is Bobo the monkey dangerous? That could be true or false. Everything happening in your code right now is state. Unpause your program, let it run, and pause it again, and all the state has changed. So here it just talks about state and what state, what happens inside of a state. So this is like a bunch of properties here. Okay, so imagine your web application is about 10,000 lines of code and use 50 classes. There are hundreds of variables. Manage all that state becomes hard. How do you keep track of things? Worse, if any part of your code can reach in and change the state of any object in your code, it's going to get really hard to understand what is going on. So to continue with the dangerous animal analogy, something made Bobo the monkey dangerous and you aren't sure what changed him and you don't know why he bit his owners. All you know for sure is he wasn't dangerous when he was created. So now you have to start looking through these 10,000 lines of codes and all these objects to find out what's messing with Bobo's state. OOP solution to this encapsulation. I'm gonna drink coffee real quick. OOP design says that we will protect our classes and our objects from unintended tampering by encapsulating them. Here's our new definition of OOP programming. The core idea is object-oriented programs to divide programs into smaller pieces, classes, and make each piece the object responsible for managing its own state. The first pillar of OOP, encapsulation. Each object should be responsible for its own state. Object A should not be able to directly mess with the state object B. So, example, no encapsulation, open example project class lesson 7. Here we have two classes, class A and class B, and the main block. Here, let's look at class A. Okay, so here the integer state is equal to 1. It's very simple. It just has one property, an integer called state. It has a default value of 1. When object A is created, this property will be set to 1. Notice the keyword public. So this is just saying that it's able to be changed from any known source. This keyword lets C# know this property is available to be viewed and modified by any other object. It's not encapsulated. Okay, let's look at the program class next and run it. So now you have about more classes here, and here you're just telling it to write line class object dot state. Okay, so this seems simple enough. We create two objects, a class A object and class B object. We run a method in class B called seem harmless and print the value of object A. This all seems pretty harmless. The class A object should have a value of 1. That's the default, and we haven't changed it. Now we checked it. Object.A state has a value of 100, not the default value of 1, but we never mess with the setting of the value of on object A. What happened? Let's look at object B. So now object B has a little bit more code into it. Here's our culprit. The seems harmless method class B was not as harmless as it seemed. Class object B grabs object A and directly messes with it. This is an example of code that isn't protected by encapsulation. So the reason this is bad is that we want to go hunt down object B and how it's working to figure out why is it changing A. That wasn't very difficult to do, which is 2 tiny classes, but imagine trying to figure out 100 classes. So now that's a lot of networking, right? Worse, the method that was messing with other object had an innocent sounding name. So imagine looking through all the classes of a giant website trying to find the classes in a line of code. That is causing our program to give us unexpected results. So how do we protect our objects with encapsulation? Example with encapsulation, C# has something called protection levels or accessibility levels. Every time we create a property or method in a class, we get to set its protection level or its level of encapsulation. So here, you just have all your keywords, public, private, protected, read only, kind of very simple and short. Public is for everyone, private is not protected. This property can be read and updated by the class, and the child class only is somewhat restricted, and then read only it would just be read only. It can only be read and not updated. And lesson 7 project only, the class called with encap. So here this part says not protected by encapsulation because it's public, and then private is protected from other classes. So here it starts with public. The class has 2 properties, one public property named not protected and one private property called is protected. The constructor auto sets the default values to 1 when an object is created. Back in the program class, you see that it has access to go in and update the public property. Program makes a change with encap class has say in it because the property is public. With encap, example object equals with new with it encap. Example object dot not protected equals -50. So anybody have any questions so far up to here? Or we're talking about encapsulation still? Okay, so but program can't change. It's protected. It doesn't see it. It's just like that. There's no as far as the program can see, it's encapsulated. This is also called data hiding. The inner working with encap class are hidden from other classes. So here, I'm just gonna have all these drop-down menus. If the program class or any other class wants to change with encap is protected property, it has to ask with encap class to do it. With encap, we create a new way to allow other classes to request permission. So here, if you want to change my protected value, you must use this. And then after you're done, it won't let you set it to a negative number because new value always has to be less than 0. We created a public method called update private property. It accepts an integer, it will update, it's protected to the new value. The key thing is to understand is that with encap, it's still in control of its own state. If it makes the change and decides that it wants to allow the property to be updated. To illustrate this, in the update private property method, we place a check on the value and refuse to update it if it asks to set it to a negative number. Okay, so these are the basic principles of encapsulation. To encapsulate data and prevent them from being used by other classes, we mark them as private. Then we create public methods that accept requests. The class that owns the property can decide what to do with the request. So why use encapsulation? If we take encapsulation seriously and use it, we should avoid the situation of class A changing class B. Only class B can make changes to class B if it's encapsulated. This makes troubleshooting a large program much easier because we should only have to look at this class itself to understand how it's changing. Be careful when creating data properties to set to public. It won't be encapsulated and it will only be open to changes by other classes. Key terms: encapsulation, lesson 7 project on GitHub. And you could also code in Unity also if you wanted to, right? So if you guys ever wanted to code in C#, Unity is also a good one, just not Visual Studio. And here you're able to code in 2D, 3D, I'll show you guys like a small example here. So here I just made a project called basketball. So you open it, you make sure you get the free version, uh, and it'll just work kind of the same way as Visual Studio. So let it load. So just got done with encapsulation. Let's talk about get and set, getters and setters. So here something pops up, right? So I'm making something like 2D. I could right click, create C# script, and then that's gonna be a new behavior. Open it up, Visual Studio will open, and I could code in Visual Studio or whatever text editor you wanted to code. And the first thing that's gonna pop up is your default value, right? Like using system, your class, then you're gonna have your method and your return value. So here, one of the important part is using the Unity engine library. And you can void start, void update, and create more classes in here or properties. Okay, so that's just a small part. Let's talk about getters and setters. In the previous lesson, we created a private field called isProtected. Then we created a public method that gave our classes a way to ask for isProtected to be updated. We even added logic to the method that refused to update the field when it didn't meet certain conditions. We can streamline this by using getters and setters. Using get and set let us apply our validation rules to our class fields and let us save us writing a bunch of extra public methods that clutter up our code. Let's achieve the same result from the last lesson only using getters and setters. Okay, so here you have both private and public, and you have a get instructing the computer to get, and you can also set if value is greater than 0, else throw a new argument. So number 1, first we create a private encapsulated version of the variable field. We choose to call it isProtected. The underscore is not required, but you only often see it used to let the developer know immediately that it's a protected field. Number 2, second, we create a public version of the field called isProtected without the underscore. This will be the version seen by other classes. Number 3, next, we write get return isProtected. This says that anytime we ask for the public version, we return the value of the private version instead. Number 4, last, we write set. These are our rules for updating the value. Notice we are updating the private version. If the value is greater than 0, we'll process the change. Otherwise, we'll throw an error, and that lets the programmer know that that value must be greater than 0. So what have we accomplished? We've encapsulated the isProtected variable from other classes, and we have saved ourselves from writing a public method by implementing a public version of the property with validation rules when getting the setting the values. The public version with get set acts like a gatekeeper to protect the private version, and using something like an underscore makes it nice and clear which version we're talking about. Next, let's look at a bad example of the wrong way. No serious encapsulation. Okay, so if you want, you could actually do this inside the C# in here too. So, so here it has a public class. And where is it? Void start, get return name set name equals value. So here you have your get set. So this is just no serious encapsulation. You'll see this example used often to teach students, and it's just bad. Our first problem is naming our variables. We have name for private and name for public. Relying on the capital letter to distinguish between two versions is a recipe for disaster. Use something that draws your attention, like the underscore. Second, make sure you guys use underscore. That's a very good way to name your files and stuff like that. Second, have we really accomplished here? We have a private variable and a public version with a get set that accepts all values. This is absolutely the same as simply making the original variable public. There's no protection here. Object A can mess with object B again, and this is just an illusion of safety. Some developers will argue that, well, yes, it's wide open now, but we can change it later, and it sets up to be safe in the future. We will argue that we don't care about the code. We will look in the future. We only care about how it works right now. So making a field read-only. Another use of getters and setters is making a property field only readable, but not writable. Let's look at an example. So here is public string read-only get, public constant string always the same, never changing value. We created a property called read-only and made it publicly available to other classes. We only given it a get. The end results, other classes can read the property. The property can be different for every object. Nothing can change the value. Once it's been assigned, this value can't be changed by anything. Contrast this to a second line of code, which creates a constant string called always the same. This value is also public and also read-only, but this is the same value for every object of the class. So here I can read the value of the public variable with the get, console.writeLine, example1.readOnly. Example1.readOnly equals error. Property cannot be assigned to. It is a read-only. Console.writeLine, example2.readOnly. This other object has a different value for its read-only property. Console.writeLine get set example is always the same. This public constant is always the same for every object of the class. So public read private set. The one final bit of convenience is this line of code. Public string, good encapsulation, get private set. This property can read publicly by other classes, but only can be written to by its own class. This will often be what you want to use to show info to other classes, but not allow updates without a method call. Takeaways and best practices. Here's a practical advice. You should strive to use encapsulation. The best thing to do is to make properties private whenever possible. Private properties ensure that other objects can't mess with this object. When you need to expose a property to other classes, you have two options. Create a public method for other classes so other classes can work with private properties. Create getters and setters so other classes can work through the public version of the property within the rules defined by the setters. Personally, this author prefers creating public methods. This is a personal taste. The downside of doing this is that your class will have a lot of public methods. The upside, in our opinion, is better encapsulation. It's easier to think about how the state is changing. Will your C# code work without being encapsulated? Yes, absolutely. To the end user, there's no difference in the outcome. But as your web applications gets larger, the code becomes easier to maintain and safer when it's encapsulated. Using proper encapsulation saves you work, time, and headaches in the long run, but creates a bit more work up front to get it set up. So here, this is about talking about get set, and you're still using encapsulation. And there's a lot of good examples of how to make it public, read only, and changing some of the values. Okay, so that's your get set. Maybe just change let's see if that would work. But its value is never used. Okay, so let's talk about our next part, which is extraction. The next big idea is in OOP is extraction, and you already seen it several times. Did you notice that as soon as we started working in OOP, we started thinking about strings, integers, and bools? and start thinking about animals, cars, and coffee mugs. When we made our coffee mugs, and when we made the first struck Mario, we're creating abstraction. Let me get a drink of water. The thing that OP does really well is model the real world. Abstraction basically means that we describe the essential details of something rather than one specific example. Thinking about abstraction, let's say our website involves cars. The customer is able to buy a car online, and the details of a car purchase are sent to the factory to have the car built and delivered. There are many kinds of cars. Cars come in all kinds of colors. Some have two doors, some have four doors, some are front wheel, some are all wheel. We don't really care about the specific detail. We want to represent this car in our code. We'll focus on the important details that all cars have in common. Okay, so here you just have your make. You have your all your details here. So string, and private. Okay, so in here I could actually do the same thing with the code with Visual Studio. So if I open this up, public. So I have a public class, new script behavior, mono behavior, and then void start. I could make it private string. Private string name. Well, let's make it public so that you could actually change it inside the value. Public integer health. Public int mana. All right. 9 through 6. Check our global logo. Okay, so now that I have all this asset, execute order. Okay, so I gotta keep playing with Unity, just messing around with it. All right, so in the code above, the car class is the extraction for a car. In the real world, there is a lot of more to a car. For example, the car might have scratches. We didn't describe the interior of a number of the miles the car has been driven. We leave out anything that isn't important and focus on providing the information needed for the program to work. If the details aren't important, we leave them out. Notice also that thanks to encapsulation, this car can't be changed after it's made. There's no way to turn a Kia Optima into a Ferrari or change the number of doors from 2 to 4. It is important that our website is able to paint the car. We could do this. Okay, so here, public void paint car. This is your start. So your paint car, and here's gonna have some of the properties in names. So here you have your red, black, blue, yellow, green, silver, and then here it's just telling you the array. Go ahead and have these options, color options. Color go into color that equals new color, and here's a statement. If available color equals new color, this color is equals to the new color. So if there's a new color, go ahead and write this part out. This is the color. If not, then this color is not available. And here is just giving you a fast program, a fast program to execute. So here it's just say Ford Mustang 2 is red. The drivetrain is front wheel. And if it's turkey, if not, then is it black? So here it says that color isn't available because we don't have turkey inside this color option, but we do have black, so it's been painted to black. So that's just a way to show a quick program of your car being either painted or not. In keeping with the principle of encapsulation, our car object is still responsible for its own state. When asked to paint the car the color turkey, the car looks through its list of available colors and only paints the car if the color is allowed. Hopefully, it's beginning to make sense that OOP programming is all about creating classes, which are abstractions, and then encapsulating them to the state is protected from unwanted or unintended changes. If this makes sense, you're really beginning to understand what OOP is. Okay, so that's a little bit about abstraction and a little bit more in depth of object-oriented programming. Okay, so let's talk about your lab. So the dating game. Right, there's like a lot of application about dating, so it's very good. You can integrate dating apps into like a lot of stuff. It's time to practice OOP hands-on. In this lab, we're going to put in to work what you've learned by creating classes for our dating website. This is a big lab, so feel free to work with partners or with your instructor as a group to complete it. So number one, I want you guys write your documents, take screenshots of all your code, write a detailed summary of everything, and make sure you guys also reference Steve, the program director, in your code if you're planning to use his code. So like, put him in as a reference. And I've showed you guys how to make references before. Put his website down, put the author and the date and stuff like that. The scenario: you work for a company that operates a dating website. You've been asked to create C# classes that the website will use to help online daters find their match. You work on a team, so another developer will be taking the code. You create and output it to your web. Your only job is to write the class code. Let's get started. Okay, so part one, create the dating profile. Number one, create a new class called dating profile. Number two, dating profile will have the following properties. First name, last name, all the properties, age, gender, bio. Dating profile needs a constructor that let us fill out first name, last name, age, and gender of the profile. So constructor is just telling the program how to behave. Dating profile will have the following methods: write bio. It's just going to be your long string of text. Read message. This will be the console that you're able to just stay on the console. And then send message, you just go ahead and enter a value so that the computer can store that. So string message title, string message data, dating profile into profile. The send message method takes another dating profile as an input and some text to the message. Part two, create the message class. Create a message class that will represent the messages. Create a new class called messages. Messages will have the following properties: public dating profile sender, string message title, string message data, and a bool is read. Create a construct that assists the value for the sender title and message data. The is read should default to false. Part three, add a message list to the dating profile. Get water again. Next, back in our data profile, add a new public property called my messages. This property will be a list of messages. Remember to add using system.generic collection to get access to the list. All right, so this is going to be a library. In the dating profile, create the send messages method. It will create a new message and then add the message to the other dating profile list of messages. Finally, in a dating profile, add another method called read messages. It should print all unread messages to the console and mark the message as is read true. And lastly, go ahead and test it out. Test in the classes, make sure there's no bugs, and go over it thoroughly. To test everything in the main in the program main method, create two dating profiles. Have one dating profile send a message, and the other dating profile have a second dating profile read the messages. Okay, so this is going to be the dating game project. So that go ahead, and before you get started, this is going to be your optional exercises. If you guys haven't already, if you finish a dating game early or feel like you need more practices, just go to adabit.com and go ahead and switch from easy, medium, hard, work around, and that's all you guys have to do. So that's going to be the end of your lesson 7. Anybody want talk about anything? All right. So